Hello, everyone. Welcome to this video. Today we are going to talk about a fundamental concept in engineering and mechanics: shear force. What is shear force? Shear force is a force that acts parallel to the surface of a material. Imagine a deck of cards. If you apply a force in opposite directions to the tops and on button on deck, the cars slide past each other. The slip is a sample of shear for in action. Where do we find the shear force? Shear force is very common in structures and materials. For example, on a bridge, the wind can exert shear force on its components. In civil engineering, engineers must ensure that materials and structures can withstand this force to avoid a failure. Practical examples: construction in a beam supporting a building. Shear force can occur due to the weight of the upper floors. Engineers must design these beams so that they don't deform or break under this force. Importance in security: understanding and calculating shear force is vital to the safety of many structures and devices. Failure to properly consider this force can result in serious damage, structural failure, and even catastrophic accidents. And conclusions: shear force is an essential force that acts parallel to the surface of material. It is crucial in the engineering and design of structures, and its correct understanding and handling are vital to ensure the safety and durability of many buildings and devices.
So, continuing with the explain, first, what is a blending moment? A moment is a rotation force that occurs when a force is applied perpendicular to a point to give a distance from that point. Is calculated as perpendicular force multiplied that is a point. It's calculated is the blending moment is simply that blending that occurs in a bend to do a moment. So this is important to remember two things when the calculating bleeding moments. The first one is the standard unit or Newton meter. On where the top fiber is compressed, the bleeding is considered positive with the definitions or the way. Let's look at keeping of calculating in this example. Yeah, for a similar exercise for we are working. Yeah, then we will cut the pin. We only consider the first and apply to the first or cut. In this case, we have a force of 10 kilonewton and it's upon directions. Now we already recall a very moment is simply force for distance, so we can move away from the first and the magnitude of the bleeding moment will increase. Hope you can see that. In the count number 2, the shear is performed just before the second force along the dam. Since there are no load applied between the first and second cut, the bleeding moment equation will remain the same. This means that we can calculate the maximum bleeding and the moment. In this case, is in the middle point of x that is similar to 5. Yeah, by simple substitution, x is same that 5 into above equation. With tricky, this could take space of the second long, first long the beam. We now have two forces acting to the left and the cut are superacting to 10 kilonewton and the non-acting load of less 20 kilonewton. Yeah, so now we're considering the forces that is moving along the beam. Yeah, for every mother we move across the beam, there will the moment are plus 10 kilonewton. This are from the first force and less 20 kilonewton for the second. Yes. But the moment diagrams can be somewhat confused when it's come to seeing conversion. Yeah, so we see the same diagram draw in positive direction depending on the source. Is no more for this part. Let's continue with the another part for another colleague of my group. Thanks for everyone.
The first step was to take exactly the quantity of 35 spaghettis, and in order to have a clear reference of its area at the moment. And the distance is 25 centimeters and radius is 0.5 centimeters. The 35 spaghettis are then joined together using tape at the ends. Several beams are built to demonstrate the bending moment and shear force throughout the equations. Two holes are made at the ends of the tube cover. This will serve as a tape of scale where the weight will added to the beam. We use nylon to tie the screw holder to the basculated. We use it and cut two PVC accessories to simulate the two supports that are at the bottom of the beam. Finally, we introduce the beam into the hole of the screw support in order to have control over weight and in any part of it.